This is Dr. M.S. Prasad, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. Today, I am going to discussing about a basic concept of chemistry, that is electrode potential. So, how we can define electrode potential? Here, potential is nothing but tendency to gain or lose of electrons. That is known as potential. The tendency is associated with electrode. That is known as electrode potential. That's why we can define as electrode potential is nothing but tendency of a electrode to gain or lose of electron is called it is electrode potential. If it is electrode gains electrons is called reduction potential. So here, what is the reduction potential? What is the reduction? Removal of electron, addition of electrons or removal of oxygen is known as reduction. So tendency of a electrode to gain electrons is known as reduction potential. Tendency of a electrode to gain electrons is known as reduction potential. Whereas oxidation potential, what is oxidation potential? Usually how we can define oxidation? Addition of oxygen or removal of electrons is known as oxidation potential. So tendency of a electrode to addition of oxygen or removal of electrons, that tendency is known as oxidation potential. Oxidation potential. So electrode potential is nothing but tendency either to gain or lose of electrons is known as electrode potential. If the electrode gains electrons, that is known as reduction potential. If the electrode loses the electrons is known as oxidation potential. A metal consists of a metal ions with valency electrons. When metal is placed in a solution of its own salt, so any one of the following reaction takes place. That is, metal undergoes oxidation. First reaction is oxidation reaction. That is, metal loses electrons when it is contact with its own salt of solution. And one more reaction is gain of electrons. When metal contact with metal ions, metal salt solution. That is known as reduction. That is known as reduction. Here, look at it. By seeing the diagrams, we can simply understand potentials of electrodes. Here, I am going to take some zinc electrode which is dipped into their own salt, that is zinc ion solution, ZnSO4 solution. Here, zinc electrode is placed into its own salt of solution, that is ZnSO4 solution. In second diagram, copper electrode which is placed into its own solution, that is copper sulfate solution. So if you look at here zinc, whenever zinc electrode is contact with the ZnSO4 solution, electrons passes into the solution. When copper electrode is contact with its copper surface solution, electrons passes from solution to the electrode. Here into the solution, here from the solution. When zinc electrode dipped in ZnSO4 solution, zinc goes into the solution as a Zn plus ions. Now the zinc electrode attains negative charge due to the accumulation of valency electrons on the metal. The negative charges develops on the electrode attract the positive ions from the solution. So due to this attraction of positive ions remains close to the metal. Next, coming to the copper electrode dipped in a copper sulfate solution. When copper electrode dipped in copper sulfate solution, copper ions from the solution deposit over the metal. Now, copper electrode attains positive charge due to the accumulation of Cu plus ions on the metal. Positive charge developed on the electrode attract the negative ions from the solution. Due to this attraction, the negative ions remains close to the metal. A layer is formed around the metal. This layer is called Elmore's electrical double layer. This layer prevents further passage of positive ions from to the metal. A difference of potential is consequently set up between the metal and the solution. Because of formation of this layer in between the metal and metallic solution, there will be an equilibrium. The potential difference becomes a constant value, which is known as electrode potential of the metal. Thus, the tendency of an electrode to lose electrons is called oxidation potential, and the tendency of an electrode to gain electrons is called reduction potential. Reduction potential. Next, coming to let me know which factors affect on potential, electrode potential. That is nature of the metal, temperature, concentration of the metal ions in a solution. These are the important factors which can affect on the electrode potential. Next, coming to single electrode potential and standard electrode potential. How we can define or differentiate single electrode potential and standard electrode potentials. First, coming to the single electrode potential. So it is a measure of tendency of metallic electrode to lose or gain of electron when it is contacted with a solution of its own salt. That is known as single electrode potential. That is indicated with E. Next, coming to the standard electrode potential. That is indicated with E0. This is nothing but measure of tendency of a metallic electrode to lose or gain of electron when it is contacted with the solution of its own salt at 1 molar concentration at 25 degrees centigrade. These are the standard conditions. So, potential of a electrode at standard conditions is known as standard electrode potential. Single electrode potential is the just tendency of a electrode either to gain or lose of electrons is known as single electrode potential, whereas standard electrode potential is the tendency of electrode either to lose or gain of electrons at standard conditions, that is 1 molar concentration at 25 degrees centigrade. That is the standard reduction potential. Next, significance. Significance of a standard electrode potentials. All electrochemical cells are based on redox reactions, which are made up of 2 half cells. So we know that all the electrochemical cells are based on redox reactions. So what is a redox reactions? Both oxidation and reduction reactions takes place simultaneously is known as redox reactions. So we know that electrochemical cell it is made up of 2 half cells. These 2 half cells are joined through a salt pitch, like that. So oxidation reaction takes place at anode, that involves loss of electrons. Reduction reaction takes place at cathode, that involves gain of electrons. Thus, electrons flow from anode to cathode. The potential that rises in between the anode and cathode is due to the difference in the individual potentials of each electrode. The cell potential of electrochemical cell can be measured with the help of voltmeter. However, the individual potential of cell cannot be accurate measured alone. It is also important to note that the potential can vary with the change in pressure, temperature, and concentration. In order to get individual reduction potentials of a half cell, it needed for standard electrode potential rises. It is measured with the help of difference electrode known as standard hydrogen electrode. So, potential of standard hydrogen difference electrode is 0 volts. The standard electrode potential of electrode can be measured by pairing with the standard hydrogen electrode and measuring the cell potential of the resulting galvanic cell. So, by using difference electrode, we can determine the potential of unknown electrode. Whatever unknown electrode we are going to determine potential, that electrode should be paired up with reference electrode. The oxidation potential of an electrode is negative of its reduction potential. Oxidation potential of an electrode is negative of its reduction potential. Therefore, the standard reduction potential of an electrode is described by its standard reduction potential. Standard electrode potential of an electrode is described by standard reduction potential. Good oxidizing agents have high standard reduction potentials, whereas good reducing agents have low standard reduction potential values. For example, let us consider calcium as minus 2.87 volts. That is the standard electrode potential of calcium. And whereas fluorine is plus 2.87 volts. That fluorine is act as a good oxidizing agent, whereas calcium act as a strong reducing agent. On the basis of potentials, electrode potential, we can design a series that is known as electrochemical series. So let us see what is electrochemical series. The standard reduction potential of number of electrodes have been measured using standard hydrogen electrode as the difference electrode. When various electrodes are arranged in order of their increasing values of standard reduction potential, on the hydrogen scale called electrochemical series. The, the arrangement of different electrodes, their increasing values of standard direction potential values is known as electrochemical series. Look at here. This is the electrochemical series. So different electrodes along with the standard electrode potential values are arranged in increasing order of their standard electrode potential values. So by taking hydrogen electrode, the potential of hydrogen electrode is 0. So the electrodes which are arranged above the hydrogen electrode are act as oxidizing agents, and electrodes which are arranged in below the hydrogen electrode are act as a reducing agents. So from above to we are going from top to bottom in this table. Reducing power increases. Reducing power increases. From bottom to going from bottom to top of the table, oxidizing power increases. So the electrode which are arranged in above the hydrogen electrode act as a strong oxidizing agents, and below the hydrogen electrode, that electrodes act as a reducing agents. So from the above series, we can understand that metals with higher negative potential are strong reducing agents. The metals with higher positive potential values are act as a strong oxidizing agents. The metals with high negative potential can depress the metal with lower negative potentials. The negative sign of the standard direction potential indicates that an electrode when joined with standard hydrogen electrode that act as a anode, and oxidation occurs at this electrode. For example, standard direction potential of zinc is minus 0.76 volts. When zinc electrode is joined with standard hydrogen electrode, it acts as a anode, and oxidation occurs on this electrode. Similarly, the positive sign of the standard direction potential indicates that electrode when joined with standard hydrogen electrode act as a cathode, and the direction reaction takes place. The substances which are stronger reducing agent than hydrogen are placed above the hydrogen in the series and have negative values of standard direction potential. The substances which have positive values of the reduction potentials and placed below the hydrogen in the series, and these are act as a weak reducing agents than hydrogen, which are strong oxidizing agents than hydrogen ions are placed below the hydrogen in the series. Next, coming to the applications of electrochemical series. What are the important applications of electrochemical series? Let us see one by one. Calculation of EMF. So what is a EMF? Electromotive force. A force which causes flow of electrons is known as EMF. So by using this formula, we can determine the EMF of the cell. That is, E naught cell is equal to E naught right side electrode and left side electrode. That is cathode minus anode. Cathode minus anode. So subtraction of potential at cathode, subtraction of potential at anode from potential at cathode. And relative ease of oxidation and reduction reactions. Higher the value of standard reduction potential, greater its tendency to get reduced. Metals on the top of the electrochemical series. For example, fluorine has higher positive standard reduction potential, that is plus 2.87, and lithium highest negative value minus 3.07. So lithium high tendency towards oxidation, fluorine towards reduction. Displacement of one element by another elements. Metals which lie higher in the EMF series can replace those elements which rise in below them the series. For example, if you take zinc and copper, standard potential for zinc is plus 0.34 and zinc is minus 0.76. So copper has a great tendency to acquire Cu form, that is copper form, neutral form, then Zn plus 2 as for acquiring zinc form. Next, hydrogen displacement behavior. Metals with negative reduction potential will displace the hydrogen from an acidic solution. For example, zinc react with H2SO4 forms ZnSO4 and H2. But silver does not react with. The metals with positive reduction potential will not displace the hydrogen from the acid solution. Metals with negative reduction potential only can replace the hydrogen from acid solution, but not metals with positive reduction potential. So these are the applications of electrochemical series. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.